Welcome to the Unit 2 review. So in this review, it's going to be structured where you guys will be doing the work and then I'll be going over the answer, and this will be completely at your own pace. So what's in Unit 2? All of these are in Unit 2 right here. Lesson 2.01, Early Theories of the Atom, the Nuclear Atom, Atomic Number and Mass Number, Ions, Isotopes and Average Atomic Mass, the Bohr Atom, Electron Orbitals, Quantum Atom, and Spectra. So that is what we will be going over today in our review. So the first unit that we'll be covering is from Lesson 1, Early Theories of the Atom. So you want to match each of these scientists to what they discovered. Number 1 is Democritus, 2 is Dalton, 3 is Millikan, 4 is Chadwick, 5 is J.J. Thomson, and 6 is Ernest Rutherford. So on the question that's going to pop up, just list your letters in order. So let's say you think 1 is C and 2 is B, you would do C, B, and then fill in the rest of your letters. Good, so here are the answers right here. So letter D was Democritus. Remember that Democritus was the first scientist that we talked about. He hypothesized the existence of small particles of matter called atomos. Dalton was C. Remember, he developed the first atomic theory, where he stated that all matter is made of atoms that are small, indivisible particles. This theory explained that atoms of one element are identical and that the combination of different atoms led to the formation of chemical compounds. Number 3 was E for Millikan. He conducted the oil drop experiment to determine the mass of each electron in an atom, and he found that to be 9.11 times 10 to the negative 31 kilograms. You don't need to know that number though. Number 4 was Chadwick, letter A. He discovered the neutron. 5, J.J. Thomson, letter B. He developed the plum pudding model of the atom, where negative particles existed in a sea of positive matter. And number 6, Ernest Rutherford, he was letter F. He did the gold foil experiment to prove that there was a large positively charged center called the nucleus, which is surrounded by electrons. So draw an atom showing where each of these subatomic particles can be located. Protons and neutrons are both located in the nucleus. Electrons are located in the outer shells. So electrons are the little blue dots, the protons and neutrons are the purple dots. Pause the video and take a couple seconds now to look over this chart. This chart is very helpful because it gives you the type of particle, the charge, the mass, number, and location. So that's really important to know for your semester exam. All right, which of the following parts of an atom did Rutherford's gold foil experiment discover? Good job if you got it right. Rutherford discovered the nucleus. Next question. So from the options given, circle the terms that represent or make up the most massive parts of an atom and put a rectangle around terms that represent the least massive parts of an atom. So the most massive are the protons, the neutrons, and the nucleus. The least massive are the electrons and the valence electrons. So point to the area on the periodic table that shows you how many protons an atom has. What is this number called? The number of protons is listed in the top right corner. That's number 19. It's called the atomic number. Point to the area on the periodic table that shows the average atomic mass. That's the number down below, the 39.10. So average atomic mass is the number below, 39.10. It's always going to be the bigger number of the two. Identify 3 elements given below, or given the information about each below. So the element that has 24 protons and 12 neutrons, 14 protons and 14 neutrons, 27 protons and 22 neutrons. Chromium has 24 protons. You know that because there's a number 24 right here, right above it. 14 protons, you'd find the number 14 on the periodic table. Here it is, Si, or silicon, is right below it. 27 protons and 22 neutrons. It's the protons that matter, so look for the number 27. There it is, cobalt, so Co. Given the amount of electrons for each atom listed below, determine how many protons are in the nucleus of that atom, assuming each one is electrically neutral. So as long as they're electrically neutral, it's going to be the same. So beryllium will have 4 electrons, 4 protons. Gold will have 79 electrons and 79 protons. Vanadium will have 23 electrons and 23 protons. An atom has a +1 charge in its nucleus. What must be true in order for it to be an electrically neutral atom? So the correct answer is there is one negatively charged electron outside the nucleus. The reason that the second part is false is because it says electrons inside the nucleus, and remember, electrons are always located outside the nucleus. The one below that, there is one neutrally charged neutron inside the nucleus. That's not correct because neutrons are neutral and they don't affect charge. The next one says the one positive proton has no influence on the overall charge of the atom. Well, yeah, it does, because it's positive, so it is going to affect the overall charge. An atom has a -3 charge in its orbital. What must be true in order for it to be an electrically neutral atom? The correct answer is there are 3 positively charged protons inside the nucleus. So if you have -3 outside the nucleus, you need to have +3 inside the nucleus.